I welcome everyone to this video. So here, this video is about complex numbers and polynomials. How do we use complex numbers in polynomial problems? So particular this problem says that if alpha, beta, gamma, delta are the roots of the equation x power 4 plus px cube plus qx square plus rx plus s equal to 0, show that 1 plus alpha square times 1 plus beta square times 1 plus gamma square times 1 plus delta square is 1 minus q plus s the whole square plus p minus r the whole square. So we're going to solve this polynomial problem using complex numbers. Of course, there are many ways of doing it. So maybe you can pause the video and try it yourself. So we begin now. Here we see 1 plus alpha square times 1 plus beta square times 1 plus gamma square times 1 plus delta square. So now I know that I can split this as this 1 minus I times alpha 1 times 1 plus I times alpha 1, where I is actually the square root of minus 1. The imaginary number I is the square root of minus 1. It's defined as I square equal to minus 1. So we can write it like this: 1 minus I alpha 1 times 1 plus I alpha 1. And once you apply the identity for A minus B times A plus B, you're going to get A square minus B square, which would turn out to be 1 plus alpha square. So we are going to continue with this. So 1 minus I beta 1 times 1 plus I beta 1. I would tell you why I'm doing this in a bit. So 1 minus I gamma times 1 plus I gamma and 1 minus I delta times 1 plus I delta. So why am I doing this? It's because sometimes we can write polynomial in terms of its roots. Like particular polynomial can be expressed in terms of its root. So if it has roots, say a1, a2, a3 for a particular cubic equation, then I can write that as x minus a1 times x minus a2 times x minus a3. Now what do we have? Say I put 1 into this, 1 minus a1 times 1 minus a2 times 1 minus a3. What do you see? It's quite similar to this, right? This, and this, and this. Maybe let me use a different color here. This, and this. So for this black line, we get when we put x equals 1. Now, how do I get 1 plus? That we will get by, maybe you can guess, we'll put x equals minus 1. So if we put x equals minus 1, what are we going to get? Minus 1 minus a1 times minus 1 minus a2 times minus 1 minus a3. So then we can take the minus as common and then we would have that. So if I use another color here, so how will we get these yellow ones? By putting x equals minus 1. So we're going to use a similar idea here, trying to express it has the roots x minus a1 times x minus a2 times x minus a3 in this case, but there we are going to have something different in this problem. So now we here do see that, let me increase the zoom to 100. Yeah, so we can see here that 1 plus alpha square times 1 plus beta square, we express this as this. So here we see that we get I alpha 1, I beta, and I gamma and I delta instead of just alpha, beta, gamma, delta. So rather than considering this equation which they've given, which has roots alpha, beta, gamma, and delta, can we in some way get that equation which has roots I alpha, I beta, I gamma, and I delta. So that's how we can think right now. So yes. So alpha, beta, gamma, and delta, the equation given is x power 4 plus px cube, x power 4 plus px cube plus qx square plus rx plus s equal to 0. So what would be the equation which has roots I alpha, I beta, I gamma, and I delta? So that is something we're going to obtain by using Vieta's relations. So if I sum up alpha, beta, gamma, delta, taking one at a time, then I'm going to get negative p here, this coefficient. Negative p by 1, so it's negative p. Now, if we add up I alpha, I beta, I gamma, and I delta, we're going to get I times alpha plus beta plus gamma plus delta, right? So now it's I times this, I times p. So in our new equation, which has these roots, the new equation, so the sum is multiplied by I, so it becomes IPX cubed. Now what happens if I sum them two at a time? Alpha beta plus beta gamma plus gamma delta, alpha delta, and all the combinations. So then I'm going to get Q. But here, if we multiply, we are going to get an additional I square multiplied with each of the terms, which I can pull out. So we'll get I square times alpha beta plus alpha gamma plus alpha delta, and all the way, all the possible combinations. So actually, this q has to be multiplied with I square in our new equation. So I square is minus 1 according to the definition of the number I. So we are going to replace this q with minus q x square. Now, what happens if I take the roots 3 at a time? Then we're going to have alpha beta gamma plus alpha beta delta plus alpha gamma delta plus beta gamma delta. But what if we do the same thing in I alpha, I beta, I gamma, I delta? You can notice similarly that you would get an additional I cube term. But what is I cube? I cube is I square into I. I square, according to our definition, is minus 1. So minus 1 into I. So it will give us minus I. It will give us minus I. So this R, which is here, would get multiplied by minus I in our new equation. So we're going to get minus IRX. Now what if I multiply alpha, beta, gamma, delta equals S? If I multiply this, I alpha times I beta times I gamma times I delta, it's I power 4 times alpha, beta, gamma, delta. What's I power 4? It's I square the whole square, which is minus 1 square, which is 1. So this S actually remains to be S plus S equals 0. So since this, we know that it has the roots I alpha, I beta, I gamma, I delta, I can write that this equation, this whole equation can be expressed as its roots like x minus I alpha times x minus I beta times x minus I gamma times x minus I delta. Right. So this is a golden equation in the problem. You could have written it in yellow rather, but yeah. X power 4 plus, yeah, this we have. Now the same thing which I told in that. How do I get 1 minus I alpha times 1 minus I beta times 1 minus I gamma times 1 minus delta? Put x equals 1, the first substitution. Put x equals 1. So what am I going to get? 1 plus IP minus Q minus IR plus S equals 1 minus I alpha minus I beta times 1 minus I gamma times 1 minus I delta. And that is going to be, if I group the real terms together, it's going to be 1 minus Q plus S plus I times P minus R. Now, the next. Next, we are going to put x equals minus 1. Put x equals minus 1. what are we going to get? We are going to get minus 1 power 4, that is 1, minus IP minus q times minus 1 the whole square is still minus q, then minus IR times minus 1. So we're going to get plus IR and plus S. This is equal to 1 plus, sorry, minus 1. It's going to be minus 1 minus I alpha 1. So yeah, it's going to be minus 1 minus I alpha 1, sorry, alpha rather, times minus 1 minus I beta times minus 1 minus I gamma times minus 1 minus I delta. And if I take minus 1 common from each of these four terms, I'm going to be left with a minus 1 power 4. That would be just 1. So we can just eliminate the minus directly here. So that's what we're going to do. So we are going to get 1 plus I alpha 1 times 1 plus I beta 1 times 1 plus, I should say just beta. Sorry for that. So 1 plus I gamma times 1 plus I delta. And this again, if I group the similar terms, it's going to be the real terms in this side. I'm going to get 1 minus q plus s minus, if I take a minus I common, then I'm going to be left with p minus r. Now, what do we actually want? We want this thing, and you can realize that it's the same thing we have got here. So we can actually just multiply these two expressions together. So multiplying this expression, referring to this expression and this expression, would give us the result, right? So I'm going to denote that by expression. I would not be writing the whole thing. It's evident from the last page. So expression, that would just be equal to 1 minus q plus s plus I times p minus r times 1 minus q plus s minus I times p minus r. Now we are going to do a simple substitution. Let a equal to 1 minus q plus s and b equal to p minus r. So what are we going to have? We're going to have a plus ib times a minus ib. So this you can verify it's equal to a square plus b square. Multiply them term-wise, you'll get to know. So now what is a? As we had made the substitution, it's 1 minus q plus s the whole square, and b is nothing but p minus r the whole square. This is what the expression we got. And what have they given? The same thing, 1 minus q plus s the whole square plus p minus r the whole square, this one. And yes, so that completes the problem. So this is our final result. So this was about this problem where we used complex numbers to solve a polynomial problem. So math is all about this, combining topics. Different topics can be combined in a single problem, and that's why mathematics is so beautiful. And I thank you for listening to this video, and I'll be back with more videos, more topics, and of course, everything in math seems interesting, right? Okay then, bye for now.